To solve this rational inequality, the first thing we have to do is set it equal to 0. So I'm going to subtract 1. So I have 5x over x plus 4 minus 1 is greater than or equal to 0. I can't really do anything until I have this combined into 1. So my least common multiple here is going to be this x plus 4. So I need an x plus 4 top and x plus 4 bottom. So on the top I have 5 minus x plus 4 all over the least common multiple of x plus 4 greater than or equal to 0. Next step, let's go ahead and distribute. So I have 5 minus x minus 4. Therefore, I have negative x plus 1 over x plus 4 greater than or equal to 0. Now this is where I need to be right here so that I can actually move forward. So I need to find the values next that make the numerator and denominator equal to 0. So I'm going to say, okay, negative x plus 1 equals 0 and x plus 4 equals 0. So therefore x here is negative 4. And let's go ahead and move the x over by adding x, so x equals 1. So these two pieces are super important. When I graph these, I'm going to look at 1 and negative 4. Now, greater than or equal to the top, which is the 1 piece, I'm going to close it off. The bottom, because of its extraneous solutions, always the denominator has to be open. So the last set here is just like we did before. We're going to test values. Well, I'm going to start with 0. Negative 0 plus 1 over 0 plus 4, is that greater than or equal to 0? So that's negative 1 over 4 greater than or equal to 0. So that is false, which means just by compound inequality notes that this one has to be true and this one has to be true. They always have to alternate. So let's just test one more. Let's try something over here. 10, negative 10 plus 1, negative 10 plus 4, is that greater than or equal to 0? So negative 9 over negative 6 really is looking at a positive number greater than 0 because 9 6 is positive, and that is true. So my final solution, let me find another color to write my end solution, is going to be this interval right here and this interval right here. So from negative infinity to 0, open, or closed 1 to infinity for the other one. There is my final solution.